Orbital Gardens, this is Mission Control. We are confirming acquisition of your signal. You are live in 5, 4, 3, 2...
Hello and welcome to episode 8 of Gardeners of the Galaxy, a podcast for all of the sentient beings in the universe who have a passion for plants. I am Emma the Space Gardener and I will be your host as we explore gardening on Earth and beyond. In this episode I'm talking to a man who spent 2 weeks on the moon. Well, not quite. Elliot Roth is an analog astronaut, and when I spoke to him he'd just returned from a 2-week mission in the high seas habitat in Hawaii. Hi Elliot, welcome to Gardeners of the Galaxy.
Hi, how are you, Emma?
I'm brilliant, how are you?
I'm doing well. It's early morning here in Los Angeles and I'm excited to be here.
Well, it must be strange because you have just arrived back on Earth after a 2-week analog moon mission. So can you tell us a little bit about what that involved?
Yeah. So I and 5 almost complete strangers went and lived in a 35-foot or about 10-meter diameter moon habitat on the side of a volcano, Mauna Loa in Hawaii, the Big Island, in conjunction with the International Moon Base Alliance and doing projects like collaborating with NASA Goddard on investigating lava tubes. Anytime that we left the habitat, we had to wear spacesuits. We were basically in this enclosed environment for 2 weeks straight. No sunlight, nothing like that. Wow. We had 2 little porthole windows, and we were running a ton of different experiments. I think I did about 12 different experiments while I was there.
Wow, that's a lot. I mean, so the idea of these analog missions is to make it as much like going to space as possible, allow people to sort of work out how we're going to live in space without actually doing the blasting off part. Mm-hmm. Okay, so one of your experiments during the mission involved researching the use of algae as a food source. So why do you think that's important?
Yeah. So ever since about 4 years ago or so, I became food insecure, and I was looking for a way to actively feed myself in a tiny space for no money whatsoever. And I came across NASA's research into algae and particularly spirulina. And so I thought if astronauts could do it, I could probably do it. So I started growing spirulina in these aquarium tanks, and then I turned it into a company. I figured out that the reason why people don't eat algae is because of the taste, and that fresh algae has no taste whatsoever. Really? And I'd not seen anywhere in literature or research in relation to kind of like space-based activities that people have been using algae as kind of that food source, kind of a protein mainstay. And it's a great idea because it's about 60% protein by weight, and it doubles every day. And all it really needs is air, water, light, and salts, and those kind of like materials you can get from human waste. And so I did a number of experiments while I was at high seas. One of them involved growing algae on simulated urine, not real urine or anything like that, simulated, and lunar regolith as kind of like an additional sprinkle on top of moon dust, right? And beyond that, what I did was I grew enough algae as a means of kind of absorbing CO2 from the local environment, reducing the amount of CO2 in the habitat. It got pretty stuffy in there. And so that really helped. It also ended up producing enough of a sample for the team to try. And on the whole, everybody thought it was great. They thought that it was really kind of surprisingly tasteless and had like an interesting buttery, creamy texture associated with it. And it's something that kind of spices up the overall day-to-day freeze-dried foods.
I can imagine. I think I saw an Instagram post or something. They say you made blue pancakes.
Yes, I did. So the main pigment component of my algae is kind of this blue pigment. So my company, Spirit Inc., we produce this as a replacement for petrochemical-based blue dyes and different kind of food dyes, cosmetic and textile dyes.
Oh, that's really interesting.
Well, the idea is to actively, like, there's 4 potential uses of algae for in situ resource utilization. So the first is absorbing and treating wastewater. And that wastewater comes in the form of mostly human wastewater. And so there have been studies that shown that different types of algae can grow on human urine. especially because it has that like high nitrate, phosphorus and potassium ratios that you need in order to fertilize things like algae and enable algae blooms. The second is CO2 capture and mitigation. By some estimates, all you really need is 10 to 15 liters per astronaut of algae growing in a given space station to bioremediate and fix all that CO2 that they're breathing out. Algae contributes to close to 70% of the total oxygen that we breathe on Earth, and was responsible actually for the first great extinction event when photosynthesis came around and actually produced all the oxygen that we breathe nowadays. So the third is mostly a matter of food, and so when you're treating all these waste materials, you're converting it into something that's actually edible, that can be used as a protein-dense, rich food source, rather than bringing a chicken into space. I'd feel really bad for the chicken on having it lay eggs, or eating the kind of like freeze-dried powders that we ended up eating, which became really bland over time. Instead, you have something that is protein-dense and able to provide that source of nutrition. It's nearly complete nutrition, as 13 vitamins, 8 minerals, 60% protein. It's really nutritionally dense. And then lastly, if you grow it on the outside of any sort of spacecraft, it forms a radiation protection barrier. And so it can be a radiation sink to protect astronauts in the event of like long duration space missions.
Wow, this is like all-purpose algae. So when you say it like that, it seems ridiculous that we're not doing more with algae at this point.
Yeah, I mean, I've talked to a number of folks, and partly it's because you want fail safes, right? And so biology is very tricky to deal with, and I found that out on our trip. The very first time I went to grow my algae, it had been in the dark for a couple of days, and I went to grow it, and it immediately died. And so I had to start over. I had some backup cultures, luckily, and I was able to get it started again. Same is true for most biology, though, is that you don't really know always what you're going to get. No. And so it's not as predictable. And in space, you want safety first. And so that's kind of the main focus. If you can get it to the point, as a metabolic engineer and synthetic biologist, I try to figure out ways to get biology into predictable patterns that you can actually estimate and use to create new things.
Okay. So now that you are back from the moon, what are the next steps for your research?
Yeah, that's a really good question. I mean, I've been decompressing, pardon the pun. I had to kind of take all my experiments and take all the data and compile that. And so I did everything ranging from biometric data collection, where I was measuring blood glucose, I was measuring sleep patterns, weight, total dietary intake, things like that, and kind of tracking that over time and seeing how the environment affected me. I did different psychological research. I was involved in 3 different psychological studies while I was there. I ended up doing a mushroom materials test where I was growing kind of mushrooms on simulated lunar regolith and space rocks and stuff that I found outside on the volcano. And then I ended up using compost and agricultural waste as a means of forming these bricks that could be used to put together different sorts of colonies. We were using LiDAR to map lava tubes and kind of culturing extremophilic bacteria that we found in the lava tubes. Some of the other kind of data points, I helped out with other experiments too. So the other scientists on the crew testing things like an ozone laundry machine, which is really cool, and found out that you shouldn't use polyester with the ozone laundry machine.
Did it melt?
It didn't melt. It just kind of smelled a little strange. Some of the other things that ended up happening were we did like a microbiome swabbing assessment. There was another crew member who was working on solving a Rubik's Cube in space. And so I learned how to solve a Rubik's Cube. She's going to solve it in microgravity, set a Guinness World Record. Wow. Super cool. And I was so lucky to learn how to solve a Rubik's Cube. And then bioprinting and working on various elements of kind of space-based manufacturing, different things associated with that. So the crew was absolutely exceptional. We really lucked out. Really what these experiments test is these analog experiments test the human element of space travel. Yeah. So rather than you can test all these different scientific experiments and whatnot, but you don't really know what you're going to get until you put the human element, the squishy bits, into space and see how people act and interact. And luckily, we had this amazing crew.
Yeah.
And I know we're going to continue collaborating and working together after this.
Excellent. So it sounds like you are going to be, the kind of person that I would want to have on Mars. You're going to be, you're going to be great. You're going to be building things. You're going to be going out and collecting rocks and doing all kinds of things. You're going to be growing things. You're going to be feeding us, dealing with the waste, producing the oxygen. So yeah, you definitely be on my team for going to space with.
Well, I mean, I figure you're going to ask, like, do you want to go to Mars or something
Yeah,
like
I
that?
am.
So we had this discussion as a crew, and most of us, all of us, really want to go to the moon. I think that's a much closer target, and that's probably the first target that we're going to hit. But I've been a fan of Venus ever since I was much younger, and I think that there's much more merit in the upper atmosphere of Venus. And I was vindicated because I came into high seas, and I told everybody on the crew, I was like, Mars, no way, no way. I'm a Venusian. I want to go to Venus. I think that people should habitate in the upper atmosphere in these airships. I think that, and I laid out all the different reasons why. It's got a really dense CO2 atmosphere. You can float air on top, shorter orbital transfer window. You don't, easier on aerobraking. You can live in internal sunshine. There's tons of CO2 to grow crops. You can convert the hydrogen, the sulfuric acid in the atmosphere into water. Tons of different reasons why, right? And then I was vindicated because while we were at high seas, there was phosphine detected in the upper atmosphere of Venus, which indicates that there's potential for life up there. And so everybody was like, well, maybe Elliot has something. He's actually speaking the truth. So I would absolutely love to go to the moon.
Okay, so if we finish up with a fun question, not that the rest haven't been fun. So I like to ask people, if you were joining a colony on the moon or Mars or Venus, and you could only take one plant with you, we're going to assume that your food needs are covered. You can have as much algae as you like. On top of that, if you could only take one plant with you, what would you choose and why?
Yeah. So initially I was hoping like I could do a cop out and be like algae and it'll be amazing.
No,
but
you
if
can
I'm
have your
already,
algae.
all right, I can already have my algae. That's a really interesting question. I think if I could take one specific plant variety, I have had this one plant. It's a jade plant, and it goes all the way back to my great grandfather. And so he's cultivated this jade plant for, I mean, it must have been. It's probably 100 years old if not older than that. And so, from like sentimental value, I'd probably bring a little leaf cutting, and then be able to grow and propagate it from that. I think that plants have this amazing psychological benefit. You just have something to care for. It's a lot easier to go about caring and gardening for a plant rather than something like a pet or a cat or a dog or something like that, or yourself most often. and so, I would probably just purely on sentimental value and making it so that there's this distinct connection and lineage to ancestry in the past, and bringing that to live with me and to grow with me. And I think that especially for a longer duration mission, it's really interesting to see how a plant grows and propagates over time. I had done a number of different studies previously on gravitropism and phototropism. And so trying to create like floating bushes of rosemary in essence. And so when you're up in space and you have the ability to grow something in a microgravity environment, like who knows what's going to happen? Because we've done it in microgravity, but we haven't done it in like 1/6 Earth gravity. And so I'm really excited to see the human opportunity and scale expand with the kind of plants, animals, and other species that come with us. If you look around at the average height of buildings, it's really limited on the basis of the height of trees, because that's the main building material that we have to work with. And so in other environments, when there's lower gravity, we have less getting us down in essence. And so we have the ability to kind of grow even greater. So I look forward to redwood forests on the moon in some aspect where they'll tower to the height of skyscrapers.
Wow. Yeah. I think your jade plant idea is lovely. I think, the idea of bringing something from Earth with so much history, that is just really nice. So yeah, I would love to see redwoods on the moon. That would be awesome.
Hmm. Sadly, on the moon, and this is what we discovered while we were in the habitat. Like you're going to be most likely living in these old lava tubes, and so that's part of the reason. If I'm advocating for Venus, if you're in these floating cities with tons of CO2, the explosion of plant life is going to be unbelievable. And so, yeah, that's probably the type of plant I would bring to Venus is that jade plant.
Okay.
I mean, as a genetic engineer and metabolic engineer, if I could choose something besides the jade plant to kind of work on, I would look at something that would be like a progenitor plant, something like in the rose family, because roses, apples are related to each other.
Yeah.
And then you have nightshades. Nightshades are all varieties that relate to each other. And there's interesting things you can do, like something called protoplast fusion, where you can actively get a potato root and a tomato plant,
I've
tomato
seen those,
fruit.
yeah.
Yeah. And so different sorts of hybrid crops, those are the kind of interesting predictive features of the Cambrian explosion that humans can create once we land on other planets. So the space industry always talks about the benefit of kind of like space to ground. So what can you do in space that provides benefit to ground?
Yeah.
So I think there truly is an amazing benefit to growing things in space. Yeah, so I look forward to that.
That would be awesome if you could have like, space farms that just like then send food down to Earth and you could have space crops.
Yeah, my dream. So I got two prospective offers to fly payloads into space, partly due to this mission. And so I'm looking forward to testing out a couple of ideas. One of them is that sort of multi-use algae-based system for wastewater treatment, CO2 mitigation, food production, and then radiation resistance. And then the other is this concept of like an edible biosphere. So if you had a kind of enclosed, encapsulated biosphere that was an ecology in a cycle with itself. And so you had something like that in a steady state in the atmosphere of space, and you brought it in and you could eat it. So that's something that I would love to test out on a satellite or a payload.
Yeah, that would be absolutely amazing. So if you get to do those, maybe you will come back on the show in the future and tell us all about those as well.
Yeah. My team at Spira is going to be releasing additional replacements, carbon negative replacements for colorants from algae. So be on the lookout for, right now we have blue out on the marketplace, but we have red and yellow as well. So we can do the full rainbow of colors. Phytonutrients and photopigments from different sorts of plant species and algae is kind of exciting possibilities of what you can do with these various colors. And so check that out if you want to go to our website at spirainc, spirainc.com. The other things that we're ending up doing is kind of creating protein and trying to design different experiments that would enable food sources on the moon, on orbital stations. And so if you want to get involved, please reach out. Our email is info at spirainc, spirainc.com. More than happy and willing to kind of take questions or get on a call with somebody at the drop of a hat. So thank you.
Fantastic. Elliot, it's been absolutely brilliant talking to you today. Thank you so much for coming on the show.
Thank you so much, Emma. It was amazing.
And I wish you well with your future research.
Thank you. Thank you.
That's it for this episode. If you'd like to hear more of my interview with Elliot, then sign up to support the show via patreon.com/Gardeners of the Galaxy, and you'll get access to the extended episode. And if you want to know more about Elliot's algae, I'll put the link to his company in the show notes for you. You'll find them at theunconventionalgardener.com. I'll be back next week with an interview with Javier Medina, a Spanish scientist who worked on the first European spaceplant experiment on the International Space Station. He also worked on the seedling growth experiments with John Kiss, who we met in episode 5. Javier is going to tell us about the challenges of growing plants in space and why it's essential that we do. Thanks for listening. Goodbye.
Orbital Gardens, this is Mission Control, confirming termination of your signal. We have activated the auto kettle and you are T minus 3 minutes. Mission Control out.